Hello everyone. Today's learning target is, at the end of 42 minutes, I can find the length of a segment in a circle that is the tangent, secant, or chord. Today we are focusing on segments. We are not focusing on angles. Let's take a look at number 1. Tangent segments drawn to a circle from an external point are congruent. Here is my external point, and these are two tangents. What is it saying? They are congruent. So the rule is that a tangent equals a tangent. CD is congruent to CB. So in our example, if AB is 15, CB has to be 15. Why? AB is a tangent, CB is a tangent, X is 15, which is CB. Our second rule that we want to learn is if we have two secants. It says, and this is a secant and this is a secant. If two secants intersect outside the circle, the product of the measure of the secant and the external segment equal the product of the secant and its external segment. So basically, our rule is whole, and I'll explain it in a second, times exterior is equal to whole times exterior. So if you look at secant B, that's the whole piece, and the little part A is the external. If you look at secant D, here it is, and the external piece is just C. So when we say whole times exterior, so our whole piece is B, the exterior is A, the whole piece is D, and the exterior is C. So B times A is equal to D times C. Let's take a look at our example. This is the whole secant, so we do have to say 14 plus 10 to get our 24. The exterior piece is 10. This is our whole secant. It's 8, and the exterior is X, and the exterior piece is simply 8. So let's do the math here. The whole 24 times the exterior 10 is equal to the whole X times 8. Quickly do the math. 240 is equal to 8x, divide by 8, and x is equal to 30. Next rule. If a tangent and a secant are drawn to a circle from an external point, the square of the tangent segment equals the product of the secant and its external segment. Also a very simple rule. What is that saying? That's saying if we take the tangent and we times it by itself, that's equal to the external piece times the outside piece. So let's write our rule down. Tangent squared is equal to the whole times the exterior. Let's take a look at our example. We have a tangent. We're going to times it by itself. We have this whole secant, which we are going to have to add together, 8 plus 4, and we have the external. So let's quickly put it in. X times x, or x squared, is equal to 12 times 4. X squared is equal to 48. Take the square root, and x is equal to 4 radical 3. Always in simplest radical form. Let's take a look at the next rule. If two chords intersect in a circle, then, the product of the measures of the segments of one chord equals the product of the segments of the other. Let's write our rule down, and then I'll explain. Product of segments equals product of segments. Let's take a look at what we have here. If you look at this segment, it's made up of two pieces, CD. If you look at this segment, it's made up of two pieces, AB. So all we need to say is A times B is equal to C times D. Let's take a look at our example. Here is one segment. Here is the other segment, and you can see they're both made up with two pieces. So 3 times x is equal to 6 times 4. 3x is equal to 24. Divide by 3, and our answer is x equals 8. The next rule that we want to focus on is a diameter perpendicular to a chord bisects the chord and its arc. So perpendicular, we know that's a pretty important word. We know that gives us congruent right angles. So let's just mark up our picture because this has got a lot going on. A diameter, AB is our diameter, perpendicular to our chord, which is CD. So if it's perpendicular, I'm going to just put in one little right angle symbol. It bisects the chord, so that means this piece and this piece are congruent, and the arcs. So now that means this arc and this arc are congruent, and this arc and this arc are congruent. So it's still, if you look at it, two chords, just like the problem above. So therefore, the rule doesn't change. It's the product of the segments equal to the product of the segments. So in this case, AE times EB is going to be equal to CE times ED. Remember that perpendicular gives us the congruent right angles. So let's take a look at our example here. It is two chords, right? We just learned that the chords, when they're perpendicular, and there's our little right angle symbol to tell us that, then we know that this chord and this chord are congruent. So it's chord, right? The two pieces of the chord, x times x, is equal to this piece and this piece. But that's a little bit trickier. We can clearly see that this piece is 2. But what is this piece here? That's a little bit trickier. Well, if you look from the center to the edge is a radius, and that's 5. Remember that all radii in the same circle are congruent. So from here to here is a radius. Oh, but wait a second. From here to here is also a radius. So if this whole radius is 5 and this whole radius is 5, this little piece in here has to be 3. So this piece right here is 5 plus 3, which is 8. So we get x squared is equal to 16, and x is equal to 4. Let's take a look at the next few problems, decide what type they are, and then you're going to pause the video and do the problems on your own and then check your answers. So you should recognize that this problem is 2 chords. And then go back and do that on your own. Here you have a secant, secant. And in number 3, you have a tangent and a secant. I want you to pause the video and do those problems on your own and then check your answers. Check your answers. And turn the page. Let's take a look at the next 3 problems, decide what type of problems they are, then you're going to pause the video and try the problems on your own. It says, given diameter AB, solve for x. So we know this is a diameter, this is a chord, and I am going to put in that little right angle symbol there so that you know that it is a diameter perpendicular to a chord. So let's write that down. Remember, it's just like 2 chords. Let's look at the next one. Oh, very simple, this one. You should recognize this as tangent, tangent. Both are tangents. And the last one is a tangent and a secant. Pause the video and do these problems on your own. Then you're going to check your answer. Check your answers. I hope you did well. That's all for this lesson. Now you will complete your 5 questions, or however many are presented on the form.